Welcome to Beyond Discovering, the podcast where we go behind the scenes of mineral exploration. My name is Thomas Tränkner and with me, as always, is Matthias Fors. Hello, Matthias.
Hello there, how are you?
I'm fine. It's a cool day when we are recording this in Stockholm.
It is cold today, yeah.
But I hope it will be much warmer when you hear this. Matthias, you are the founder of Geopool and you are also the person who took the initiative about this podcast.
That is true. I wanted to somehow extend the knowledge about what exploration is all about and not so much discuss about mining, but more what is the exploration and how it works.
And today we are going to talk about geochemistry. And at its core, geochemistry is about how chemical elements are distributed in the rocks, soil and water and why. So what is really geochemistry in your...
In my word.
Your word.
Yeah. Well, geochemistry and geochemical sampling is one of the tools that we are using within mineral exploration in the early stage of the program. So you have geophysics, you have geological bedrock mapping, but the geochemical mapping or geochemistry is then when we are taking samples from the overburden to evaluate if there is elevated content of some metals.
And all this is helping to understand what might be hidden beneath the surface before the drilling takes place.
Exactly.
So, but let's start from the real beginning and talk about what types of mineral deposits exist in Sweden.
Yeah, so most of the mineral deposits in Sweden are very old, often around 1.9 to 1.8 billion years. And in Sweden we have several different geological settings. So there is VMS deposits, you have porphyry copper systems, there is orogenic gold deposits, and we have magmatic nickel, copper and PGE systems, and of course iron ore.
Yeah, which is the most common mineral in Sweden.
That is true, yeah.
But why do certain metals occur together?
So depending on where we are in Sweden or within which geological environment we are, these bedrocks have then different elevated metals. For example, we have in porphyry copper systems, we have quite often higher copper and molybdenum. And in VMS system, you have zinc and lead, which is quite common. And when we then do geochemical sampling, we are trying to recognize this combination, which help us understand in which environment we are, or if there are elevations of these elements.
And the core thing is that metals does not appear randomly.
No, so it's a base of they have been in, all metals have been in the bedrock back in the days, but then from the ice transportation they have immobilized and moved away from the bedrock and now are in the gravel and the soil.
And if you know all this and know these combinations, the explorer can interpret much better the geochemical data.
Yes, so quite often when you're doing a geochemical survey, you lay out a grid, and that could be, for example, 100 by 100 meter grid, and you sample then each point, and if you have then an elevated copper, for example, in one, it gives you an indication of one of the samples, it gives you some kind of indication, but if you have several samples in a row, having elevated copper, for example, that it gives you an indication on where you are.
Matthias, what does a high metal value really mean?
Well, if we are in geochemical sampling, it doesn't really mean we still have made a discovery, but if we have found a set of samples in this grid that has elevated mineralization, that indicates a pattern that we are closer to something, and quite often then the next step is to do an infill soil sampling program. So instead of doing 100 by 100 meters, You do maybe profile lines, or you do 20 by 20 or 50 by 50, and trying to get closer to find the uppermost sampling point with elevations of this metal that you're searching for from the ice direction perspective.
Let's talk about gold, and why is it so difficult to find gold?
It is challenging. There's basically two different types of gold mineralizations, quite common that we have here. One is free gold, and that is then bedrock that is scrapped, and you have quartz veining coming up through the bedrock carrying free gold. So there are no associated metals. But then you also have other type of gold mineralizations. For example, where it's combined with arsenopyrite, antimony, and bismuth, and these are then formed during another type of geological processes, and that in those cases, then when you are in these areas, you are not using gold as the first element you're looking for, but you're using these associated minerals when you're doing the geochemical sampling.
It's really unpredictable.
It is challenging, yeah.
But it will never get out of interest.
No, I mean, gold is both used in technology, in mobile phones and computers and so on, but it's also a currency in a way that people invest in instead of relying on the currencies around the globe.
Let's continue this talk about mobility of elements and why some are less mobile and some are more mobile. What metals are less mobile than others?
Well, so when you have the geochemical sampling program, and if you find, for example, copper and nickel, these are quite less mobile, so that means quite often that you're closer to the deposit. When you have a more mobile element, could be arsenopyrite, for example, or arsenic, that means that you're maybe further away from the source of the mineralization.
So what does that mean when we talk about geochemical anomalies, how they appear, these metals?
So it depends, of course, on the thickness of overburden and different ice directions movements and how many generations of ice flows you have had in this area. So it might tell you nothing, but it can also reveal that you find something that you want to follow up on and continue to explore.
Another thing that might also be used for detecting possible minerals is vegetation. Can you talk about that?
Yes, in different areas and where we have higher content of different elements. Let's take copper, for example. If you have higher copper in the soil, it then also, of course, depends if the soil is of gravel or sand or mud, what kind of soil you have. But, for example, the vegetation also varies depending on this. And there's one copper flower called Viscaria, Silene Viscaria, which is quite common in this. And so basically what I'm saying is that in some cases you can also use vegetation as an indicator of the area that you're interested on, if there is higher metal content in the soils or not.
And from all this, we learn that all the knowledge about this is very important to make an efficient drilling strategy. Because drilling is the only way to really find what's in the ground.
Exactly. So these geochemical samples are just as an indicator. But you need to get closer to the bedrock, and you want to find the source in the bedrock when you are doing drilling. So the closer you get with soil sampling, it gives you the better signals of what grades or content we have in the bedrock.
Interesting. So, Matthias, let us summarize this to some good advice for the listener.
Geochemical sampling is one of the, I would say, early stage exploration methods. In some areas, you have historical information that you can gain or use. But if you're moving into a new area where mineral exploration hasn't occurred before, Geochemical sampling is one of the methods that is quite often used. So you go out there in the field, you have a shovel, and you take a small, 200, 300, 400 gram sample, and with that you get a first indication on if there is mineralization in the overburden. That doesn't mean we have mineralization in the bedrock directly under, because the ice direction, movement or transportation can be, 1 or tens of kilometers transported. So then you need to backtrack and try to find up ice direction where the mineralization is in the bedrock.
So you can say geochemistry helps the explorer to drill smarter and not more.
Yeah, well, exactly. You need to find and use the available methods before you go to drilling, because drilling is expensive.
Yeah, and it reduces risks and saves money.
Yeah, and soil sampling and geochemical sampling is also a low impact method. So it doesn't, you can do it by walking. You don't need equipment for it. So it's also, in that way, a good exploration method.
Great. Thank you very much, Matthias.
Thank you, Thomas.
And the listener, please subscribe to this podcast so you don't miss the next episode. See you.
See you.
Bye-bye.
Take care.